Hello there and welcome again to my workshop, to another Carveco tutorial. I do notice on the Carveco information pages people are asking where are the tutorials. There are literally hundreds and hundreds of tutorials. They're all linked to ArtCAM. Carveco is ArtCAM, just under a different banner, that's all. So to get to them you can either go into Google or whatever your search engine is, go into YouTube for tutorials for ArtCAM. Or if you want to, if you're watching this video, go to my channel page, come over to this side, scroll down, oh, wrong computer, scroll down and you will come to ArtCAM. Okay, and the easiest way I have found, of course this is under the banner of Autodesk, but these tutorials still apply because it's the same program. Okay, so the easiest way to look at these, I suppose, is just go to videos, bring them all up. And you can scroll down through. Obviously these are about actually making 3D reliefs. For newcomers that might be a bit complex, but if you scroll all the way down, there are many simpler ones. These are still 3D. Actually these are using ArtCAM reliefs. You got 2.5D there. This is a good one. I've actually done that one myself. I've actually done that one. But you can follow along as you can with any tutorial. But there's very, very good information in here, and it does apply to the Carveco program. I'll prove it to you in a moment. So, sign making, simple sign making, 2.5D carving, coin making, and mold making. Now this is where I started. I started right back 11 years ago, and some of the tutorials here, I mean I can remember, sort of making a 3D relief by color. All these still apply, and this is where I started 11 years ago, and this is how I learned. So, and I suggest you to do the same. The project today that we're going to put together in Carveco, you can view the machining of it in my video 297. So this is the Carveco opening screen when you open the program up. So you need to go into this top corner here where it says new model, click on that, and this dialog box comes up. Now the first item you need to deal with is the X and Y size of the material in X and Y. Now the bar stock material that I use for this job is in the X was 105mm by 50mm. Okay, so that's the bar stock size that's set. Incidentally, this is a machining into solid aluminium bar. So now this is the start of the program. Okay, so you can start in the middle and any corner. Now for this machining operation, for this I carried this out on a milling machine, a CNC milling machine, which is normally this back, you set the 0, 0 in this back corner. This is actually what is known in G code as the G54. Now you really don't, it's just a label that's given to it, and it's really not necessary to sort of pay a large amount of attention to the actual label, other than this is the start position of the whole job. So the computer running the machine actually knows exactly where its start position is in relation to the working envelope of the machine. So that's the 0, 0. I normally leave this resolution slider bar in the middle. It's fine, and obviously we're dealing in millimeters, so we're going to OK that, which will take us into the program screen. This is the 3D screen actually at the moment, but we want 2D. So I'm going to start with the outside. Okay, now this little aluminium container was purpose made for a job. So we're going to get the square or rectangle. We're going to just do that. Now there's a couple of things we need to do here in this wizard or dialog box. And the first thing is the actual size. Now the actual size of it was 100 millimeters, and it was 48 millimeters. 48 millimeters. So you can see now that the box now is jumping, as we're altering here, it's jumping to the correct size and position, or close to it. Now I wanted rounded corners, and I wanted a 6 millimeter radius. So there it is, there's the radius, 6 millimeter. But I want this object to be set right in the center of the stock bar material. Now to do that is fairly easy, and it is actually set right in the middle. So ArtCAM has determined that yes, I wanted that right in the middle, and it's put it there, and now we can create that. And there it is. So we can get rid of that. Okay, so the next operation we need to do is to copy this vector, and a vector is any line on the screen. Any line, any shape at any angle, it's a vector. So we need to copy this vector inwards 2 millimeters, and there is a tool to do exactly that. That's this one, and it's commonly known as offset vectors. So we'll choose that one. We want to copy this inwards, and we just want to see, you can copy 2 either side, outside or inside, a specified amount, and the specified amount is 2 millimeters, because we want a 2 millimeter wall, and radius corners, yes. We have the choice here of deleting the original vector if we wish. Okay, so this is now okay, so we can offset, and that's exactly 2 millimeters in, which is just under 1/8 of an inch. So we can get rid of that, and we can click off that. Now in the center we want the central boss. Okay, so we take our, if you notice, when we get somewhere near the center, I have snap turned on. So when we get near the center, you notice that the cursor changes, telling me that I'm at the center. I want this to be minus 25, that's correct, minus 52, and it is in the center. That's telling me, do you remember the bar stock was 105 millimeters long? So that has gone right in the center. So it's telling me that it is in the material center. That is exactly where we want it. So we create. And we can actually, to save ourselves a little bit of time and effort, by drawing another circle, because we want to drill a hole there, we're going to use this tool again, and we're going to offset inwards. Now we need to offset inwards 3.5 millimeters, 3.5 millimeters inwards, radius. This is all okay, offset. So basically that is our part that we need to machine. So now we will go to the machining operation. This is a straight 2.5D machining operation. So we come up here to tool paths. It's a 2D operation, and the first thing we're going to do is machine the profile around the outside. So we choose profile. So select a vector. Okay, so you're telling the program, and in this case the wizard, that, well, this is the part I want you to machine. I want you to machine it on the outside, so you can, you know, select the along if we wish. The center of the tool will go along it or inside it, as depicted on the little diagram here. But in our case, we want to profile the outside, and it's the selected vector. We've already selected it, so the program knows exactly what we're talking about there. This we can leave alone. It's you know, it's a radii, so it'll just follow it around. Start depth 0. We want to start at the top of the material, and we want to finish 16 millimeters down. Okay, tolerance 0.025 millimeters. That's fine. It's not an absolute precision. The ML that we're going to use is this one. It's an extended 8 millimeter 3 flute. Okay, see the 3 cutting faces there? 3 flute. Beautiful. This is a tungsten end mill, very long lasting, and it doesn't exist in our tooling list. So we're going to create a tool in the tooling list. So what we're going to do is choose a 6 millimeter, copy it, and choose the one above, which is the copy, and we're going to edit it. So this is just representing an end mill. It really doesn't matter about the number. So we're going to put here 8 millimeter. Millimeters per second, that's the feed rate. And diameter 8. This is okay, we can leave that, because that we can change all that. All these numbers we can change when we go into okay, so now we can change the actual speed and feeds. Speed and feeds, here we go. Now, and this is where you change the speed and feeds, or select the speed and feeds for a particular job. Now, you must sort of, in the back of your mind, have an idea, okay, what is the material and what will the tool and the material withstand in cutting. Step over. Now I've got quite a small, it's a converted SIG X2 milling machine. It's only a little 350 watt motor, or 375 watt motor. So it's like half horse. So it won't withstand a great deal. I mean, it does the job okay. So we're going to say we want to step over, and the step over is how deep into the material that it will go. 3 millimeters, a little bit too much for it, maybe. It possibly could do it. In actual fact, the maximum step over we require is 2.5 mil. We're going to say 3 millimeters. We're going to say 3 millimeters here, because that's, you know, we want to do it in one go, and we're going to ensure that we do it in such a rate that it's capable of handling. 2 millimeters. Now that's step down, so each time it goes round, it's going to step down into the material. 2 millimeters. 76 millimeters per second of feed rate? I don't think so. This is very high. This is set for a commercial CNC router, or even, you know, something like a Haas or something like that. So we're going to say something in the region of 12 millimeters a second, but bear in mind, whatever I set in here, I can alter it in Mach 3 to, you know, 10% of that figure if I wish, which will be 2 millimeters a second, which is very, very quiet. I normally set the plunge rate of half the rate of feed rate, so that's 6. And don't forget, this is going into aluminium. Now I know that flat out, that little SIG, and the way I've got it belted, will do 4,000 RPM. I don't have a tool changer, so that's not going to matter to us. Now, climb milling, yes, if you have the option, always climb mill. It just cuts an awful lot better. Add lead in and lead out moves, definitely. Distance and diameter, oh, that'll be, I'm going to go 10 millimeters. Cut. 5 millimeters. So what I want to do, if you've got the material, piece of material, this will do. So what I'm doing with this, a lead-in move, because I'm going to run in around this outside, I want it to come into the side, then start going around, but I want it to come in gently, you see. So that's what I'm setting these figures up. I'm saying, well, come in 10 millimeters, then come in gradually. Ramp from surface, there's no need to ramp for surface, but this is what I want. I want it to come in at a nice segment then, sort of like this, as depicted in here. And I want, yes, radius 5, because I set the distance here 10, so I need a radius 5 to come in. And you see on the video, indeed that's what happens. Ramp moves, I will include ramp moves, zigzag 10. there's no need to. No, there's no need to. This will sort it, actually, because this will do it right from the very first cut. That'll handle it. No need to do any more there. Cut sequence, no. This is okay. Safe. 20mm safe area above the material, that's fine. Now let's define the material. Now what you've got to think of is, okay, I have the material clamped in a vise. How much am I going to have sticking out? So I know safely if I can grab hold, you know, I can clamp 3mm, and I know I want to come down 16mm, so that leaves me 2mm clearance between where I'm cutting and the top of the vise. So I'm going to tell this that the material thickness is 18. And model position is in the top. This is all okay. Yeah, model position top. 0 is in the top. Okay, I'm going to OK that. Okay, so now we label this. Now I abbreviate everything. Cannot calculate for the following reason. Leading distance must be less than or equal to the radius. See, now I made a mistake here, albeit a deliberate one to show you. The radius here is 5, overcut is 5, distance, diameter 10. So actually that is supposed to be 5. Now that's the beauty of this program too. There's that much thought gone into you know, the making of this program, and over the years the modifications to the program, that you know, it won't allow you to make a mistake if possible. So calculate now, and it's done. So now we can get out of that one, and there is the tool path there, and here's the lead in and lead out moves. So it's indicating, it's showing you it's done. So what we're going to do now is what is known as an area clearance. So we want to machine this area out now between the inner wall area and the outside of this. So you select that. So notice now this vector is showing that it's been selected, but what you do, you press shift and select this vector as well. So when we select the machining operation, you'd say between the selected vectors. Okay, so toolpath, still a two-dimensional operation. It's an area clearance and selected vectors. That you have a choice. Okay, so selected vectors. So we've selected the vectors, so it actually knows that you want the inside material machined out there. Now then, start depth 0, finish depth 14mm. Tool allowance. So now we need to add a tool to machine this. Open, 8mm, there it is. We put it in the tooling list before. We're going to use the same tool to clear this out. I'll select that. Okay, so we've selected our tool. Now we're going to set the parameters. Step over. We're going to make this easy life on the tool. We're going to say 2.5 millimeters. Step down of 2. And there again, 12. Not forgetting we can alter this in Mark 3. It's not set in concrete. 6. 4,000. Doesn't matter to us about the... And this is set right for us. We want to do an offset. In other words, we want to come in with the tool. Want to come in with the tool, and it will start in the middle here, and it will machine from the center and work its way out and then go like that. Not come in and go back and forth. That's not the way to do it. In this sort of circumstance, you need an offset. Climb milling, always use climb milling. Inside start point, start in the middle of the material. Independent finish depth. Now let's see if I wanted to do a finish cut. I don't want to do a finish cut. Add ramp moves, definitely. 10 degrees, 10 degrees, that's okay. Minimum ramp length, I'm going to 10 millimeters. Zigzag height, 5 millimeters. So that means it's going to come into the material. It's going to go zig. It's going to go zig, zag, zig, zag, zig, and go into the material gently, not come in and go ugh. Okay. This is all set up. This is fine. So this is the second cut. So I abbreviate everything as I've said. Cut 2, 8 millimeter and mill. Oh, let's say where it is. So this is the inside. Okay, calculate, and there it is. And we can get rid of that one. So we've done the outside, we've done the inside. Oh, facing operation. Actual fact, I forgot about that. So what we need to do is face off the top first, actually. So we can do that now. It's no great drama. Now, for me to machine the top off this, I have to draw an additional vector. Now, I'm just going to get rid of some of these lines that are let's turn these off. There we go. So what I need to do, so I can face off the whole material, is draw a box. I'm going to use a big 19 millimeter tool. So I'm just going to draw a box around the outside there. It doesn't have to be an exact size, as long as it sort of overlaps, so I know that I'm going to machine the whole and not miss any. So we can get out of that. Okay. I've actually pulled up this now. You can get to the tool paths up here, okay, but you can actually get to them here as well. So select the vector you want to deal with. Area clearance in 2D. So selected vectors, which is that one. Start depth 0, finish depth. I want to take off 1 millimeter. One millimeter. Tolerance. Okay. I'm going to have to make another tool because it's not in my tool-in list. So, copy, pick the top one, because it's going to be a larger size. Edit. 19 mil. Ooh, step down. I'm just going to say 2mm. You know, I can alter this, you know, on each job. 15,000. I'm going to leave this as it is because I can alter it then on the job. Select. So here it is. Let's have a look. Step over. Do you know that's 1mm depth? That's probably okay. I'm gonna run with that. Step down. I want to do this in one cut, 1mm. Feed rate. Oh, I'm going to go 10mm a second. Plunger rate 5mm. So I go 50% of whatever the feed rate is. I find that works. In this case it's going to be 2000 RPM. Tool number really doesn't matter. In this case I want to do a raster. So that means I'm going to come in here and go back and forth and work my way across the material. 6.5mm each step in. Ramp moves, I always use ramp moves. This is okay. This again is okay. I know exactly what that is, so I can leave it at that. And then it is done. And I know I'm going to get all the material in. There's not going to be any left there. So I can turn these on now. There we go. Visibility of all tool paths. So okay, so we got one left now, and that's a drilling strategy, and that's this one in the middle. And okay, so we come up here. To the drilling. Start depth 0, finish depth, no, I only want to go in 10mm, just a little bit of a thread out in there. 10mm. Punch clearance 2mm, that's okay. Select the tool. I'm going to do this with a 3mm end mill. Select. Select vectors, that's correct. Use peck drilling, absolutely. Now what peck drilling is, it's like a bird picking corn. It's going to come in, drill a millimeter, come out, another millimeter, come out, another millimeter, come out, and so on and so forth. It all gets all the way down. So it means that it brings out the material and gives you know, chance for the fluid, the coolant, to flush out whatever's in the left in the hole. So that's what we're going to do now. So retraction, I need to retract 5mm. Auto, leave that on automatic. Machine surface, home position. This is all okay. So that is our part. So what we'll do now is go to the 3D and we will get our twiddle button or tool. I'll move it up and we'll put this at an angle like this, and we're going to say that, well, let's simulate the tool paths. It's only a small job, so we can do it standard. So here we go. Oh, I didn't say it. See, no, I made a mistake there. So what we're going to do is we're going to simulate all tool paths, not just one. There we go, there's the outside. Here comes the inside. I think my computer is busy sort of there you go. It's updating Windows, I think, in the background, so it's made it a little slow. But that's what we're going to end up with. So the next thing to do is to save the tool paths. You can either come here and press Save Tool Paths, or you can come up here and get to Save Tool Paths here. So we'll do it here, and there's many different ways of doing it. It depends on what your machine is. To move them around, you just select them and use the arrows to move them from one side to another. So it's up to you whether you want to which one you want to start with first. But I would probably start with the face-in, which is the 19mm, and save it to wherever you want. One word of caution here: there are many different G-code ways in which Carveco will save. For a house or anything like that, it's got certain code that's, certain G-code that is made for it, and this is what they call a post processor. So, but normal machines like a Tormac or something like any CNC router or anything like that, you come here, normal G-code millimeter tap or G-code inches tap. All machines understand that, unless you have a specific machine. So you just save it to wherever you want to, removable drive, or save it into a file in your computer, and that's basically how to do that. Okay, so I hope you've enjoyed this Carveco tutorial today. This tutorial set out really for the beginner, to set you off on 2D design and simple machining. You really need to get a handle on that first before you start machining 3D parts. So thank you for joining me, and please like and subscribe, and also subscribe to the Carveco and ArtCAM tutorials, and even Facebook for Carveco, because there's a lot of good information on that. So I hope you come and join me again for the next installment. So from me now, it's bye for now.